My project is on like I basically made a machine learning model which could predict rain. And it's specifically for um, it's specifically a classification model to predict the rainfall in Sydney. So what I did was I took a data set from Kaggle, which gave the weather data for uh, like all the cities of Australia, and I took the subset of Sydney, um, uh, and I applied a class. I turned it into a classification problem, basically. So this has the following input features: date, location, temperature at like four different times, min max 9 a.m., 3 p.m., rainfall, evaporation, sunshine, humidity at 9 a.m., 3 p.m., pressure, and cloud at those same times. And finally, rain today, which is a categorical column, and the output feature will be rain tomorrow, which is what we have to predict. Okay, so for this project, the stakeholders are agriculture and farmers, because planning irrigations, sowing, and harvesting schedules can be improved with this project and reduce crop loss from unexpected rain. Um, there is also water management authorities. Why? Because we can manage the dam more effectively because of the rain prediction and flood risk assessment and early warning systems for the same reason. Then logistic and transport companies for optimizing shipping and delivery schedules and preventing delays due to bad weather. And finally, insurance companies that take care of the property insurance planning, estimating risk for weather-related claims. Okay, so moving on. So data preparation was done by removing the irrelevant columns, one hot encoding the categorical columns and imputing the missing values with the mean. And data is finally like prepared for machine learning by splitting it into train and test data. So for the baseline model, we take a classified decision tree and we check its performance. And next, we use bagging with the decision tree to improve its performance. And for further models, we use a random forest. And after evaluating the scores from it, we finally use grid search CV to identify the best hyperparameters for the random forest model. Okay, so the number of data points is around 3000, and the missing values were 16.9%, almost 17. And the train and test data were split as follows. This is a heat map for null values. Let me just move this here. And so we can see that most of the null values are in cloud 9 a.m. and cloud 3 p.m. And moving on, just move this here again. Okay, so data was cleaned basically by removing the date and location column because they're not relevant to the model. We one hot encode the rain today and rain tomorrow columns because they're categorical. We split the data into X and Y and impute the missing values with mean. And as we discussed, these are the models we use. And metric used are mean squared error, R2 score, and accuracy score. So this is just the details of the grid search CV, like the parameters and the max features and the min sample split that were inputted to find the best hyperparameters for the random forest model. Um, so the results are that for the classification decision tree, the mean squared error is 0.194 on the test data, which is not bad. The accuracy score is 0.82 and 0.80 for train and test data respectively. So that looks okay too. But for further improvement, we try bagging with classification tree and we find out that the accuracy score is 1.0 and 0.83 for train and test respectively. So it has slightly improved in the case of test data. And then next we use random forest and we see that the accuracy score went down a little bit. As you can see, for classification tree plus bagging, it was 0.83. For random forest, it is 0.823 for the test data. So finally, we use random forest plus grid search CV and we get the highest accuracy score up until now, which is 0.8357. And this is the code link and the dataset link for from Kaggle, and that's pretty much it. Thank you.